Welcome to another Mr. Paul video. In this lesson, we'll be discussing 4.2, determining slope and y-intercept. This is going to be a two-part video. I wish I could connect the two videos together so it's one streamless thing, but I'm not that tech savvy. So make sure to watch the second video for today. This is going to be one of two. So first off, we're going to start with determining the slope and intercept, but we're going to start with stuff that we already know, okay? So if you have ever picked fruit with your parents, like you went out into the fields, one of the things that they do is when you show up in the morning, they tell you you don't really get paid. You don't get paid until you actually pick some fruit and you fill up the crates, you fill up the cases, you fill up the flats, whatever you're picking. For me, it was cherries. So if you wanted to get paid more, you had to pick more. So if you picked a case, let's just say that one case is worth $30. If I picked a case of fruit, I'll get paid $30. But as a kid, when I was younger, my parents were like, hey, I'll give you $20 just for showing up because I know for sure that you're not going to pick nearly enough. So my parents were sometimes nice. And even though I picked 0 cases of fruit, I still earned $20 for that day because I was spending a whole day. I just wasn't very good at it. However, if I was to pick one case, remember, I'm getting $30 for each case. If I picked one case, that's $50 because that's the 30 for the case and the 20 that my parents would give me. If I picked the second case, I would get $30 for each of the cases. So it's 2 times 30, which is 60. And then 60 plus the original 20 will get me to 80. Go ahead and pause the video now and fill out these next 2 empty spaces. If you didn't pause the video, means you're just watching it straight through. Kudos to you, but I wanted you to try and do this by yourself. If I picked 4 cases, I don't want to put a number here without thinking this through. Because I have some students that are like 20 going up by 30 is 50, going up by 30 is 80, going up by another 30 should be 110. But I really don't want to get cheated, so let's just do some math here. If I get 4 cases at $30 a piece, that's $120. $120 plus the additional 20 is $140. If I was just to go up by 30, you would see that I'm not getting paid as much. Remember, the relationship between the cases of fruit and the money earned is not the same as the relationship between 1 case and 2. Okay, so be careful. If I picked 10 cases at $30 is $300 because 30 times 10 is 300 plus 20, I would have $320. Okay. So I want us to start thinking of these cases of fruits as X's and these dollars earned as Y's. And today we're going to be learning about something that relates these X's and Y's in a new way. So let's just think about what we already know about proportional. This is a unique situation in which an X and Y are related, but 2 things have to be true. 2 of them. Both of them have to be true. You must go through the origin. Which means that you go through the point 0, 0. It means 0, 0 would be in the table. Remember, a table and a graph are the same thing, just looking a different way? You have to go through the origin on the graph, meaning the table must contain 0, 0. Also, must be a straight line, meaning the rate is constant. Okay, the rate is constant, meaning if it was in a table, each time I picked a case, I would get $30. I wouldn't get 30 for my first case and then 20 for each case after that. I'm getting paid paid $30 per case no matter how many cases I pick. The rate is consistent, is constant, is the same every time. In the non-proportional, this is what we learned yesterday, non-proportional. That is the situation that we have here, meaning does not go through the origin. In fact, it goes through 0, comma b. 0, comma b, and I'll explain what this is in a moment. 0, comma b, not 0, 0, 0, b. However, still must be a straight line, meaning that the rate is constant. The only difference that we're changing from proportional to non-proportional is that we're no longer going through the center. We will still be dealing with straight lines, just as if it was proportional, which means that the rate stayed the same when looking at it visually through a graph. But we're going to go through a different location other than the origin. Take a moment to pause this video. I will be erasing the rest of this and moving on. So go ahead and pause your video now. Hopefully by now you have this all written down. I'm going to erase this, and we're going to introduce the whole point of today's lesson, which is, how is this actually related? How are these x's and y's portrayed in a non-proportional setting? So I'm going to finish erasing this. And we're going to start with y equals m x plus b. Now, when talking about word problems, we've seen some of these before. Okay? The y's were always known as our outputs, and our x's were known as inputs. That's true the same way that it was last year. We do know that we have two new elements. We're used to seeing a k here because this was a proportionality concept. It's no longer proportional, so they changed the letter on us, but it still stands for the rate. This is still a rate. The new entry into our word problem setting is this thing called an initial value. What that basically means is, where are you starting? If it's 0, we started at 0. If it's 10, we start at 10. Where do we start? In the example that we did in the video, we started at $20. So this B would be a 20. Now, when we're talking about graphing, this M and this B take on names that we've heard and seen before, but now we're going to tie it together. So this is when graphing. This M will take the purpose of a slope. Remember, rates, while graphing, are called slopes. This B, when graphing, this is going to be known as our Y-intercept. And that's the topic that we discussed at the beginning of the year. This is our Y-intercept. Now, one last thing to conclude this video. What do these things look like? Well, we kind of know what slopes look like. And we know them as the change in y over the change in x. That's what we decided last week. A slope is how much the y changes compared to how much the x changes. From here on out, we're going to have an easier way to remember this. We're no longer going to say the change in y over the change in x because we like to make our lives easier. We're slowly becoming mathematicians. We want to be lazy. We're going to call this the rise over the run, which means the rise, like a sun rises, is how much our y's are changing. We're not changing with a process, we're changing what it's called to make it easier for our brains. Run is how much the x's are changing. Okay, so think of the rise as the difference up and down, and the run as the difference between left and right. These are all the same thing. I'm not changing it, I'm just making it easier to remember. Y-intercepts can look a couple of different ways too. We will know them as b is equal to some number or 0, b. So in the previous example, when we had in the table when the initial value was 20, we could say that b is equal to 20, or we can say the location is 0, 20. In the next video, I will be showing you what this looks like on a graph. I wish I could connect those two videos together, but I cannot. So once you're done with this video, click on the next one right below it, and I'll show you graphically how these two things are related. How does changing a slope and changing a y-intercept look graphically? That's all for this video. Peace.